So today we're learning about the area of trapezoids, rhombi, and kites. So we're going to start with a trapezoid first. So a trapezoid, remember, has two parallel sides. Those are the bases. And then the perpendicular distance between them is that height. It has to be straight at a right angle. And then our formula we're going to use is area equals 1/2 times the height times the sum of base 1 and base 2. So if we're looking at our first example here, we have to find the area of this trapezoid. If we plug in our answer, we have area equals 1/2 times the height, which is 38, times base 1, 72, plus base 2, 85. And then we can just type that into our calculator. So 1/2, or 0.5, times 38 times 72 plus 85. And that will give us that our area is 2,983. So area equals 2,983, and our units are inches, and since it's area, it will be squared. Okay, so our next two shapes are the rhombus and the kite. Again, rhombi just meaning plural of rhombus. So for a rhombus, if you remember, it's just a slanted square. So all four sides are congruent and then opposite sides are parallel. And then with a kite, it has two sets of congruent sides, and the short sides are congruent and the long sides are congruent. So they actually get to work the same way, which is to find the area, you just do 1/2 D1 times D2, diagonal 1, diagonal 2. So I wanted to show you that a diagonal is just corner to corner. So that could be D1, this could be D2. Same thing with a kite. D1 and D2. So those are the diagonals that you're going to use in that formula. So you just do diagonal times diagonal and then times 1/2. Okay, so here are two examples that we can use for our rhombus and our kite. So we have a rhombus first, which has 6 millimeters marking right there and 7 marking the spot. So what we actually need to do is we need to do the total of each diagonal. So if this piece is 6, so is that one. So the total diagonal is 12 millimeters. And then the same thing for this diagonal. So if that one's 7, so is that one. And that will be 14 millimeters. So then we plug it in. Area equals 1/2 D1 times D2. So 1/2 times 12 times 14. So 0.5 times 12 times 14, and we get 84. So the area is 84, and since it's area, it will be millimeters squared. Our second one is a kite, and they've actually already shown us what the full diagonal lengths are, 16 and 9, so we don't need to do any work to get those totals. So we just plug it in. Area equals 1/2 times D1 times D2, so 16 and 9. So we would do 0.5 times 16 times 9. And our area for this kite is 72. So area is 72 inches squared. And so that's how you find the area of a rhombus or a kite. Okay, so for our last example, we're going to be using the area to find missing measures or just find missing parts and then solve for whatever we're asked for. So on A, we have a kite, and the area is said to be 92 inches squared. One of the diagonals is 22 and the other is x. So 92 equals 1/2 times 22 times x. Well, half of 22 is 11. So I'm going to divide by 11 on both sides. And I kind of skipped a step there, so if you need to do more steps, that's fine. But 92 divided by 11 is 8.36. So we're going to say 8.4. So our answer is 8.4 inches. So we found that missing measure. For our second one, B, is a trapezoid. And we have areas 177. So we have 177 equals 1/2 the height, which is 13, times base 1, 11, plus base 2, x. We don't know that. So then half of 13 is 6.5. So you could do it that way, but I probably wouldn't, honestly. So I would probably do times 2 times 2. And again, you can work this algebra however makes most sense to you. So 354 equals 13 times 11 plus x. Again, I'm probably going to go ahead and divide out that 13. Then I would just have that 11 plus x. So 354 divided by 13 and get 27 we'll call that 2 equals 11 plus x. I'm going to subtract 11 and get 16.2. So our answer would be 16.2 centimeters. And then for our last one, we actually have to work a lot on this kite to kind of get the missing parts. So this is a right angle. That's 10, which means that this side is 10. That's 17, so this is 17. We know that these two pieces are equal from when we learned about kites, but these are not. So just because that's 6 does not mean the long piece is 6. So we're going to have to do a lot of Pythagorean theorem here. So this little triangle, if we pull it out so you can see it, we know that this is 6 and this is 10. So we need to find that piece. So we would do 6 squared plus x squared equals 10 squared. 6 squared is 36. 10 squared is 100. Subtract 36, and we get 64. Take the square root, x equals 8. So this piece is 8, which means that piece is 8. So we now have our first diagonal, which is 16 inches. So for our second diagonal, now that we know that's 8, so again, let me draw what that would look like, just so you can kind of visualize. This was now 8, and this is 17. So this would be our x this time. So we would do 8 squared plus x squared equals 17 squared. 8 squared equals 64. 17 squared, I think, is 289. We would subtract 64, and that should be 225. Yep, and then take the square root and get 15. So this missing piece is 15, which means our diagonal on this side has the 6 plus a 15, which is 21 inches. So now area equals 1/2 d1 d2. So half times 21 times 16. So 0.5 times 21 times 16, and we get 168. So our area is 168 inches squared. So when you're missing pieces, you can just use all the rules you've already learned previously in geometry to be able to solve for those, whether that just be some simple algebra or having to use Pythagorean theorem.